Hello, welcome to this week's Adventures in Astronomy. Don't know about you, but I'm struggling a little bit with the night skies at the minute. We're getting about 45 minutes of complete darkness at the minute, and I just don't image in those kinds of conditions. I'm waiting for that to creep up to 2 hours in a couple of weeks' time. So I've been thinking about other ways of processing, and I thought I'd try something that I've never done before, which is to develop James Webb Space Telescope data, which is freely available and on a public site, so there's no reason not to do this if your skies aren't dark enough. So it was a bit of an experiment, and I found that there were 3 hurdles to overcome, and I'm going to show you those hurdles and how I overcome each one. One of them is fairly small, 2 of them are a little bit bigger. And after I'd processed the picture of the Eagle Nebula M16, which you can see on screen, I posted it on Cloudy Nights forum and had some lovely comments. Thank you everyone who's thumbed up and comments. I wasn't actually looking for comments. It was just more, I'd put a post up about it being quite an interesting process. Without further ado, I'm going to show you how to, first of all, download the James Webb Space Telescope files. And this is where we meet the first hurdle. First of all, you need to go to this website. I'll post this in the description of the video, this mass.stsci.edu site. And the first thing that you want to do is just simply click on the tab that says Advanced Search. And that will bring you to this over-facing looking scary web page. It's not quite as bad as it looks, but what you will see straight away is, don't worry if you don't feel something's happening on this website. It takes a little while. It's not dependent on the spec of your computer. It's on the database that's held off-site, presumably on some sort of remote server. But if we look over here in this records found section, it's still trying to find all the records that it's got in its database. So there are 3 things to search for in here, but you're going to have to be patient because it doesn't always show up straight away. So in the name, the first thing I did was type in M16 and press enter, and that will put in the applied filters the M16 Eagle Nebula in there. So that was the first thing to do. The second thing to give it is in the mission box, you want to be searching for James Webb Space Telescope. Now, there are only 18 different kinds of space probes out there taking photographs, so it's sometimes a little bit easier to just show all of that and click on the James Webb Telescope, and you can see it starts refiltering there. And the final thing that you want to do is in the instrument box, because you're looking for the near-infrared images. So if you just type in NIR, that will search it down. You're looking for NIR cam/image. Once it's searched for that, and it will take a while, you then want to be hitting this button up here, search. Now, to save time, I've already done this in another window up here with the search applied. And what you'll then find is just 6 files, or you should find just 6 files. And just at this point, just note something here. You've got these file names that say FO9TWF, but they all start with F. Those are quite important for data in a minute. You can download them then. Just a little tip, if you click on these stars here, you can actually add the products to a download basket and then go to your basket and download all the files all at once. They're pretty hefty files, so they can take a little while. Now, once you've got all the files, there's a little bit of clear up to do, and that is to say, delete all the files that you've downloaded, apart from the ones that end in I2D fits files. All the rest is just rubbish, and you can get rid of it. So this is hurdle 1 overcome, hopefully, because it wasn't easy to navigate this database. I do think navigating this site could be a little bit easier, but then fair enough, at least the data's there. So that's hurdle 1 overcome. Okay, so moving into PixInsight, you can see my working file, and we'll get to that in a moment. What I want to show you is what the files look like when you first open them. This is just one of those 6 files. If we do a screen stretch on there, you can see lovely data. It's a little bit annoying because it's brought in quite a lot of other stuff. There's flats, there's rejection algorithms. The good news is you can delete everything behind it. You only need to keep the file in each occasion that says i2d.fits. So I'm going to minimize that, chuck it over there, and you can just delete the rest. Once you finish that process, you should end up with 6 files. Now, a little bit unusual because we're used to having narrowband files and luminance red, green, blue, perhaps. What do you do with 6 images? Well, the first thing that you need to do is rename them. Just shorten those names so you've got just those F numbers that you took from the database, and put them in some sort of order. And I'm going to explain why now. If you go to the user documentation file for the James Webb Telescope, there's a sort of technical manual in there that tells you about what is in all of these filters. And there's a very useful diagram here that I've actually copied across into PixInsight. I would suggest you do the same if you're going to do this project, because it really will help. What you can see is that these file names do roughly correspond to areas of the spectrum in color. And so you can start to see roughly how to map the colors. So this F090W is this sort of purple signal here. And you can check on each file name. If we look at this F335, that is over here. There's this yellowy, greeny signal here, going all the way up to F47090, which is quite deep red. So this diagram is definitely very useful, and it's definitely worth having in terms of understanding the data that you've got. Now, if we just take a look at the kind of data that we've got here, we've got lovely data, but there are obviously stacking artifacts here. And the next step I want to take you through is really important. Do not crop these images. And the reason is, if we just go back to this diagram here, you'll notice that you've got some shortwave channel lengths and some longwave channel lengths. If we look at some data from the long channel lengths, which would be this F44 image here, and you look along the bottom of PixInsight, you'll notice the width is 765 pixels by 4177. But if I look at one of the short wavelengths, you will notice that there's a completely different width down there of 14,340 pixels. If you crop them, what you're going to get is a blocky image when you combine the images. So do not crop them at this stage. Your first job is to star align these images. I would recommend that you go for a short wavelength filter in the middle, which would be F200W as the reference image, and then you add all the other filters in, and then hit that apply button, and you will get star aligned images, which are what all of these files here are. And if we lay one on top of another, if we get a short and a long wavelength, you'll find they match nicely, but also you'll notice that they match in terms of width. And if I click on this one, also match in width. Then you can crop them. And if I go to my history and I look at F090WR as an example file, so the register file, all I've done is put a dynamic crop on each of those and blur exterminator. With blur exterminator, just a little recommendation that I'm going to make: don't sharpen any of the stars. The stars are a little funky in James Webb Space Telescope data. We'll come to that later in this video, but I have just sharpened the non-stellar. That should give you everything you need to overcome hurdle number 2. And that is, how do you combine this data to get one nice image to work on? Well, I had a little bit of help from ChatGPT and Claude and Gemini, and they all spat out similar formulas. Let's have a look at what is going on in each one. So in the red channel, what it's telling us is we want a strength of 1 on the reddest channel over this area here, followed by the 444W channel, which is here at 85% strength, and then just 25% strength on this slightly green yellow filter over here. That will give us our red channel. And if we just very quickly look at the green channel, you'll notice that they're sort of within this region here. And of course, the blue channel filters are all in here. Now, I will copy those PixelMath formulas into the description of the video so that you've got them. Once you've got that, you can combine your data. You'll have a combined image that looks a little bit like this with a stretch. And that's a linked stretch. So we just open the screen transfer function and we unlink the stretch. We've got an image that starts to look okay. Obviously, the colors are way off at this stage. We've also got some stars that look a little bit weird. That's to do with the James Webb Space Telescope design, and you can probably see this substructure appearing in the stars, and we can fix that later on. That's hurdle 3. So we've just overcome hurdle 2 in terms of getting the right color balance. It may not look right at the minute, but we're going to very quickly fix it. So I'm going to show you the sequence of steps that I took to get this image towards the final image now. But to save time, and so that we're not making this a 3-hour tutorial video, I'm going to whiz through these steps because most of you will be able to follow along with this pretty quickly. So the first step to do when you get this data is to do background neutralisation. By the way, don't do anything like SPCC. This is James Webb Telescope data. It's not regular data. It doesn't always work well. So you're best off using the old tools to get this done. So background neutralisation and colour calibration. And if we just restretch that data, that's looking okay at this stage, and then remove the stars. And I did that with Star Exterminator, and it did a pretty decent job. And then we're going to do a stretch, but we're not going to do a full-on stretch. We're going to do a gentle stretch. If I just turn off the screen transfer function, you'll see it's a slightly dim stretch. The reason I did this is because I wanted to do the rest of the stretching in generalized hyperbolic stretch, GHS, and I wanted to give myself a little bit of room for maneuver. So you can see in the history, if we go back to this, there are several tweaks on this and focusing on different areas. We've now got a nice stretched image. And then it's a matter, if you look at this history, it's a matter of now putting on different color masks and getting the colors right. If you can see this color mask script here by Bill Blanchard, and you basically work on finding yourself the right kinds of masks. First of all, what's really nice with this data is you can very clearly see the purpley blue channel, and there's very clearly a yellow come red channel. And so using this script, I was able to generate pretty decent looking masks that covered those whole areas. That's the one for the yellow channel and the one for the blue channel. So I did a bunch of these. You can magenta, there wasn't loads in there. And I even did one just for the head because I did a little bit of work on this head. Working through the steps, you can see I started working with the blue mask originally to get those hues about right. That's with the yellow mask on, so you can see that start working on the yellow. At one point in the process, this didn't look right, this bottom left, because it feels like it sort of stands out separate from the rest. So I actually developed a yellow mask 2 version where it just focused just on that area, and I clone stamped out the rest of it. Carry on going through these curve steps, and you can see it sort of, let me just move this over here a little bit so we can see a little bit better. So you can see that yellow mask version 2, it's now become a little bit more subtle. And I carried on going with that. These were the steps on the head. This was just go back a step. This was just to, if I can just zoom in here, this was just because I was starting to lose a little bit of the detail. So I did some curves in there. Each step, you obviously want to be going into the curves tool, looking at the separate channels or the RGBs or the saturations. That's an example of one of the curves that I used. And then we got it to a final stage where I was actually pretty happy with it. All I did was some local histogram equalization. Now, word of warning on local histogram equalization as well. That wasn't at my regular settings. I actually did a 12-bit process. It's pretty processor intensive if you're going to do that. So it can take a few minutes to run even on a decent spec machine. And then I actually used Cycon parallax at the end just to up the sharpness levels a bit. So if we just zoom in a little bit and go before and after, you can see just a subtle change. I'm going to really zoom in a little bit more and then just do that before and after step again. And you've got a bit of blurriness and then slightly snapping into focus. So that's Psychon Parallax. I've got a separate video on that if you want to know how to use that. It's pretty decent software. So there we are. We've got a finished image apart from the stars. So how did I deal with the stars? Well, challenge 3 is that the subtracted stars look a little bit like this. But you might notice a problem even at this view. If we start zooming in, like I say, we've got these holes all over in the data. The way to overcome that was to look at some of these separate images. Now you'll notice in the shortest wavelength that actually that hole there isn't quite as bad as what is on our image underneath. What I did was went to the first 2 images where the stars were looking pretty decent in the main, and I removed the stars from both of these wavelength images and combined those images together simply using PixelMath. The equation is simply F187N _R add the 090 file. I then stretched those into a luminance image. And the final step couldn't be done in PixInsight. I like to stay in PixInsight wherever possible, but I actually went into Affinity Photo. I copied in that TIFF image of the stars. I then loaded up the luminance file. I don't think this was the one that I used, but it's near enough to give you the idea. And then I basically copied that into a layer here. And then all I did was just put the plus on there and change the channel layer to add. And we can see pretty much that that's done a fairly decent job of hiding those nasty cores. And then the final step was to just do a little bit of clone stamping to clear that up, bringing it back into PixInsight until I had a star's final image. Now they're not perfect, and I wanted to leave them slightly unperfect, and there's a reason for that. I wanted to deal with the real nasty stars, but actually there was a sense of, if we look at this smaller one here, there was a sense that I actually wanted to leave a bit of a James Webb Space Telescope mark in the image, if that makes sense. I hope it does to you. I didn't want to kind of clone stamp the whole thing out. I was also feeling a bit lazy, if I'm being honest, and didn't want to do that sort of level of work. I would if it was my own data. And I basically used another Bill Blanchard process, script, cosmic photons, and screen stars to add stars back in, and rotated the image, and that was it. Image finished. If we zoom in and have a look around this, the data is pretty incredible. If you want to follow this process and really clone stamp that out and go for that, by all means do. You're probably going to get a better image than I've got, but I'm quite happy with the finished process. I hope that's been helpful. 3 hurdles, like I said. Hurdle 1, downloading the data. Hurdle 2, how do you combine the 6 color channels? Hurdle 3, dealing with the stars. Hopefully that helps everybody this week. Definitely worth doing. I'm really glad I did this. I've never used publicly available data like this before. Get over to the MAST site, go and download, it doesn't have to be M16, something else, and go and see what you can produce with it. Because it's free data, the skies aren't dark yet, why wouldn't you be using PixInsight to do something processing wise? I hope you've enjoyed today. I hope it's been useful to you. My name's Martin. You've been watching Adventures in Astronomy. Hope to see you next time.